In this video, I'll focus on circular motion and then I'll be solving various problems concerning horizontal circular motion. So I'll advise you don't skip around this video. In order to solve some problems on circular motion, you need to be familiar with some formulas. The formulas can be gotten from the formulas that are used to solve equation of motions. For instance, the first equation of motion, which is v equals to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, t is time. And then there's another one, s equals to the average of the initial final velocity plus the initial velocity multiplied by time. Okay, where average velocity v average is equals to half v plus u, v squared equals to u squared plus 2as. Okay, and then we also have v equals to ut plus half at squared. Okay, not v but h or s. In circular motion, instead of having v, which is supposed to be in the final velocity, okay, in circular motion we'll have omega, which is the angular speed, okay, or angular frequency. Alright, so as the final, I'll have it as omega 2 then equal to the initial angular speed, that's supposed to be omega 1 plus a, which is the acceleration. So I'll write it as this to show that it is for the angular acceleration. Then I'll have this. Okay, and then for s, that's supposed to be s right here is supposed to be the distance. Okay, but for circular motion I'll have it as the angular displacement, which is represented as theta. Okay, theta can be referred to as the angular displacement. It can also be referred to as the number of revolution, that is how many revolution is made round the circular part. A complete movement, for instance, if a car moves from this point, all right, if a car moves from this point and then ends at this point, it just made one revolution. So the distance along that circular path is the angular displacement. It is also the number of revolution. It is also the angle through which the object turns. Okay, so the angle is given as theta, which is equal to half then omega 2 plus omega 1 then multiplied by t, where t is the time taken. And then we have the other one, omega average. Okay, that's the average angular speed or the angular frequency. That's supposed to be half of omega 2 plus omega 1. For this right here, v squared, I'll have omega 2 squared, which is equal to omega 1 squared plus 2 alpha s. You know, s is the distance, so we'll have it as the angular displacement. Okay, and the other one, which is s equals to ut plus half at squared, my s is supposed to be theta, and that's supposed to be equal to omega 1t plus half alpha t squared. Okay, these are basically the formulas that are used to calculate the distance along that circular path, where omega is the angular speed or the angular frequency. Okay, now I can also have some other formulas which we use based on the question. For instance, if you are asked to find the linear speed, the linear speed is given as v equal to omega r. Okay, where v is the linear speed, that is the speed along the circular path. Okay, but notice that omega in this case is the angular speed. The relationship between the linear speed and angular speed is that the angular speed is multiplied by the radius to produce the linear speed. Okay, and also it can also be referred to as the tangential speed. It can also be referred to as the tangential speed. Okay, so it can also be referred to as the tangential because it is the speed at every point on the circular path. At this point, at this point, every point on the circular path. So it is the same thing as the tangential speed. It makes the object moves in this direction, in this direction. Okay, in this direction, in this direction. But there's another force, there's another speed which helps it maintain that circular path and is directed towards the center. That's the centripetal. Okay, so that's supposed to be the centripetal acceleration. All right, so we also have centripetal acceleration. Centripetal acceleration, it is directed radially inwards. Okay, directed towards the center of the circle. Centripetal acceleration, which is equal to, well, the symbol for that we can make use of a, which is supposed to be v squared upon r. That's the formula for centripetal acceleration. V is the linear speed, okay, where v right here is the linear speed or the tangential speed. All right, we can also have tangential acceleration, that is the acceleration at every point. That means if the velocity right here, which is the linear speed or the tangential speed, if it changes with time as the object moves along the circular path, there will be an acceleration. Okay, so that means there will be a tangential acceleration as well, which is directed towards this point. So as the object moves this way, tangential acceleration at every point is in this manner, and there is centripetal acceleration in this manner as well. Okay, so that means we may need to find the net acceleration at this point. So this is the net acceleration, this is the tangential acceleration, and this is the centripetal acceleration. So in order to find the net acceleration, I will just make use of Pythagorean theorem. Since it's already a right angle triangle, that means I'll have centripetal acceleration squared plus tangential acceleration squared. So that's it. So the formula for tangential acceleration, I'll represent that with a sub t. Tangential acceleration, that's supposed to be, it is the product of the angular acceleration with the radius. Okay, it is just like the linear speed. Anything linear or tangential has a relationship with the angular. Okay, and the relationship is always the product of the radius multiplied by that physical quantity. So the relationship between tangential acceleration and the angular acceleration, okay, it is this equation right here. Just multiply the angular acceleration by the radius. Okay, but notice that angular acceleration can be gotten by this simple formula over t. Yeah, okay, that is the difference in the omega. You know this formula from the equation of motion, v minus u over t. So that same formula is what we can use to find the angular acceleration. All right, so the tangential acceleration is also referred to the linear acceleration, that is the acceleration along that circular path, while centripetal is directed towards the center of the circle. All right, so there's also angular displacement. Okay, we can also have the linear displacement, the linear distance, or the linear displacement to be equal, the linear displacement L. Okay, the symbol is just L. It is equal to theta r, that is the relationship between the linear displacement and the angular. Notice that theta, angle theta right here, is the angular displacement. L right here is the linear displacement. So the relationship between the linear displacement and the angular displacement is for you to just multiply the angular displacement by the radius to obtain the linear displacement. So those are just the basic formulas. Okay, the angular speed of a disk decreases uniformly from 12 to 4 rad per second in 16 seconds. Compute the angular acceleration and the number of revolutions made in this time. Okay, it decreases uniformly, all right, from this. That means that is actually the initial angular speed. So omega 1 is equal to 12 rad per second, and then omega 2 is equal to 4 rad per second. Okay, and then the time taken is 16 seconds. So we want to compute the angular acceleration. The angular acceleration alpha is omega 2 minus omega 1 upon the time. That's supposed to be 4 minus 12 upon the time, which is 16 seconds. Okay, and that's of minus 8 upon 16, and that's supposed to be minus 0.5 rad per second squared. Rad per second squared is the unit of angular acceleration. To find the number of revolutions made in this time, notice that number of revolution is angle theta, okay, and it has a lot of formulas. It is given as L upon R. It can also be found using the equations of motion, but since we don't have the linear distance, all right, so we'll consider using the other equations of motion, like theta equals to half omega 1 plus omega 2 then multiplied by t. Alright, so we'll have the half omega 1, which is supposed to be 12, plus omega 2, which is supposed to be 4, multiplied by the time, which is 16. Okay, so this is supposed to be 16 all over 2, and that's supposed to be 8 multiplied by 16, which is equals to 128. So that's supposed to be 128 number of revolution, but I have solved in, I made use of 12 and 16. I have solved in rad. Okay, since I made use of 12 rad per seconds, 4 rad per seconds, and then 16 in seconds, so that means the answer is supposed to be in rad. But to convert it to revolution, 1 revolution is equals to 2 pi rad. Okay, that means if I want to find how many revolution would make 28 rad, I will just need to divide. That means if I cross multiply, I will need to divide by 2 pi. So if I divide by 2, if I cross multiply, I have 28 rad equals to x into 2 pi rad. So if I make x the subject of the formula, I will have 28 rad divided by 2 pi rad. Okay, so I just need to divide 128 divided by 2 pi. 128 divided by 2 pi, okay, will give us the number of revolution. Alright, so pi is actually 22 over 7. So 2 pi is 2 times 22 over 7, and then 128 divided by that is equal to 20.37. So I'll have 20.37 revolution. Okay, so that's it. A 120,000 gram car accelerates from rest to a speed of 40 meters per second in 5 seconds at a constant rate on a circular track of radius 800 meter. What is the tangential acceleration? The tangential acceleration A sub t is the product of the angular acceleration multiplied by the radius. Okay, let's see if the radius is given as 800 meter, and then we can find the angular acceleration, which is omega 2 minus omega 1 upon t. Omega 2, that's supposed to be angular speed, the final angular speed. Okay, and the question says that the object accelerates from a point of rest, that means omega 1 is actually 0, okay, to a speed of 40 meter per second. So okay, no, we will not be able to make use of this formula right here to find the angular acceleration. You know why? Because we are not given the angular speed. Okay, omega 1 right here is not 0. Okay, omega 1 is not 0, and then omega 2 is not equal to 40 meter per seconds. Okay, by the unit of omega 1 and omega 2 is supposed to be rad per second because they are angular. Okay, so but we can also make use of the angular acceleration formula, which is v2 minus v1 upon t. We can use this directly to find the tangential acceleration. Okay, we can make use of this to find the angular acceleration. We can also make use of this to find the tangential acceleration, and this as well. Okay, so the final speed v2, which is supposed to be 40, and then v1, that's supposed to be 0, the initial, upon the time, which is 5 seconds, and that's supposed to be 40 divided by 5, which is supposed to be 8 meter per second squared. Okay, now to find the centripetal acceleration, the centripetal acceleration is given as v squared upon r. Okay, where v is the linear speed, and that's supposed to be 40 meter per second squared, upon the radius, which is 800. 40 squared, that's supposed to be 1600. Okay, and then upon 800. Okay, that's supposed to be 2 meter per second squared. And then to find the net acceleration, this is actually what happens. As the object moves along the circular path, there is a particular tangential acceleration, and there is a particular acceleration towards the center of the circle. Okay, and we can find the net acceleration. Net acceleration is like the total, it's a vector, the total acceleration of the object as the object moves, okay, along the curved path. So this straight line up here, this vertical distance, is the same thing as this vertical distance right here because they are parallel. Alright, so if I call this the net acceleration, and I call this the centripetal acceleration, and then I call this the tangential acceleration, that means I can find the net acceleration using the Pythagorean theorem because it actually forms a right angle triangle. So the net acceleration is equal to the root of tangential acceleration squared plus the centripetal acceleration squared. Okay, that's the square root of 2 raised to power 2, that's 4, and the other one, which is 8 times 8, that's supposed to be 64. So 64 plus 4, that's supposed to be 68. So I'll have the square root of 68. Square root of 68 is about 8.24. Okay, meter per second squared. So that's the answer. Now to find the net force, notice that net force that is acting on the car, net force is proportional to acceleration. Okay, that means the net force will be proportional to the net acceleration, and that will be the net force will be equal to the mass of the object multiplied by the net acceleration. Okay, the mass of the object is 120,000 gram. 120,000 gram is the same thing as 120 kilo because these 3 zeros is represent kilo. Kilo means 1000. So I'll have 120 kilogram. So the net force is 120 kilogram multiplied by 8.24. Okay, 120 kilogram multiplied by 8.24. So I'll have 989.55 Newton. Okay, so that's the force, the net force that is acting on the car due to the net acceleration. A wheel revolving at 6 revolutions per second has an angular acceleration of this. Okay, find the number of turns the wheel must take to reach 26. So that means omega 1 is given as 6 revolution per second. If I convert it to rad per second, since the acceleration itself is in rad per second, the angular acceleration, and that's supposed to be 4 rad per second squared. Okay, revolution actually means 2 pi rad, so I can just have 6 multiplied by 2 pi rad per seconds. Okay, so 6 times 2 pi rad per seconds. Alright, for the other one, which is omega 2, the question says we should find the number of turns the wheel must take. The number of turns that the wheel must take is associated with the angular displacement. Okay, that is how many revolution, how many turns. So that's the angular displacement we are looking for. Omega 2, which is equal to 26 revolution per seconds. Okay, the number of turns the wheel must take to reach 26 revolution per seconds. So that's supposed to be 26. Revolution means 2 pi rad. Okay, then per seconds. So 26 multiplied by 2, that's supposed to be 52. So omega 2 is actually 52 pi rad per seconds. And then this is supposed to be 12 pi rad per seconds. Now to find the distance, the angular displacement, we can make use of a lot of the formulas, but I will just make use of the formula which is related to omega 1, omega 2, and the angular acceleration, which is omega 2 squared equal to omega 1 squared plus 2 angular acceleration and then this. Okay, alright, so omega 2 squared. Okay, I would like to first of all make angular displacement the subject of the formula, minus omega 1 squared equals to 2 alpha theta. Okay, that means I have subtracted omega 1 squared from both sides of the equation, so that I will just have to divide through by 2 multiplied by the angular acceleration. Alright, so if I do this, the theta, which is the angular displacement, would be omega 2 squared minus omega 1 squared upon 2 and then the angular acceleration. Omega 2 squared, that's 52 pi squared minus omega 1 squared, that's supposed to be 12 pi squared upon 2 multiplied by the angular acceleration. The angular acceleration is just 4. Okay, so if you multiply 52 pi squared, that's supposed to be 26687.41 minus 12 pi squared, that's supposed to be 1421.22, all divided by 8. Okay, so the difference is supposed to be 25266.1903 upon 8. So if you divide this correctly, you should have 3158.274 rad. Okay, since we actually solved in rad, Okay, we solved in rad per second squared. That means the unit of that angular displacement will be in rad. But we just need to convert it to revolution because we are dealing with number of turns. So to convert it to revolution, we just need to divide by 2 pi. Okay, so if I divide it by 2 pi, if I divide this figure by 2 pi, 2 pi is actually 22 over 7 or 3.142. So if you divide it by 2 pi, the number of revolution, which is angle theta, will be equals to 502.65 revolution. Alright. To find the time that is required from the question, to find the time that is required, we may just make use of this formula right here. Since we have been given the angular acceleration, which is this, notice that angular acceleration is omega 2 minus omega 1 upon t. If I make t the subject of formula, omega 2 minus omega 1 upon the angular acceleration. The second angular acceleration, that's supposed to be 52 pi minus 12 pi upon 4, which is supposed to be, and that's supposed to be 40 pi upon 4. 40 pi upon 4 is the same thing as 10 pi. 10 pi is the same thing as 31.4 seconds. Okay, so this is the seconds, and that's the time taking. So it's as simple as that. Alright. A car wheel 30 centimeter in radius is turning at the rate of 8 revolutions per second. When the car begins to slow uniformly to rest, that means the final angular speed will be 0, or the final angular velocity will be 0 in a time. Okay, the time is given. Find the number of revolution. Number of revolution, that's angle theta, made by the wheel, and the distance the car goes in 14 seconds. We need to find the distance of the car, and we need to find the number of revolution by the wheel. Okay, now to do that, the initial angular speed is 8 revolution per second. Okay, 8 revolution per second, and then the final, which is supposed to be 0, and then the time taken is 14 seconds. To find the number of revolution, we can make use of some equations, and the equations that will comprise of these three physical quantities, I think that should be theta, which is equal to omega 1t plus half, then angular acceleration, then t squared. If this will not help us, we can make use of this half omega 1 plus omega 2 multiplied by t. I think this will be nice. So I'll have half omega 1. If I solve in revolution, that's 8 revolution per second plus 0. Okay, and then the time. Okay, 8 revolution per second plus 0, so I don't need to include that. Then 14 seconds. So this is supposed to be 4 revolution per second. So if I 4 revolution per second multiplied by 14 seconds, that means the seconds we just have to cancel out, so that I will have 4 revolution multiplied by 14. So that's just 4 times 14, which is 56 revolution. To find the distance the car goes in 14 seconds is like finding the linear distance. And notice that the linear distance L is the product of the angular displacement multiplied by the radius. Okay, the distance the car goes in 14 seconds. The car is actually moving in this way. Notice that L, which is the linear distance, is the same thing as the circumferential distance. That is distance along the circumference of that circle. Okay, so the distance, like for instance from this point to this point, is the L. Okay, so it is at a particular angle where this is the radius r. There is another, from this one to this one is another radius. This is at angle theta, and that's why theta is always equal to L upon r. Okay, so that's it. Actually, it is supposed to be the sine of angle theta, because sine is opposite. It's supposed to be sine theta, which is supposed to be opposite upon the hypotenuse. So L is the hypotenuse in this case, and I mean R, which is the radius, is the hypotenuse, and then theta, and then L is the opposite. But notice that the sine of angle theta is very, very small, so it can be approximated to theta, and that's why theta is always L upon r, and that's why L is equal to the product of angular displacement and r, and that's why sometimes theta can also be referred to the angle at which the object is being displaced, or the angular displacement. Okay, so the distance the car moves is L. Now we have found the number of revolution, which is the theta, which is the number of revolution. We got that as 56 revolution. If we multiply that by the radius is 30 centimeter. Okay, 30 centimeter, that means I'll have 56 multiplied by 30. That's supposed to be 1680 revolution centimeter. But I can decide to convert it to rad. If I convert it to rad, let's say from this point, and I convert 30 centimeter to meters, then I should have 56 multiplied by 2 pi, and then multiplied by 0.3. Notice that 30 centimeter is the same thing as 0.3 meters, because centi means 10 raised to power minus 3, so I'll be dividing by 10 raised to power minus 2, so I'll be dividing by 100. So if you multiply these together, you should have 105.5 meters. Okay, so which is approximately 0.11 kilometer. A mass of 1.5 kg out in space moves in a circle of radius 25 centimeter at a constant 2 revolution per second. Calculate the tangential speed, which is also the linear speed, is the product of the angular speed and the radius. So the object moves at a constant 2 revolution per second. That means omega is 2 revolution per second. I can convert it to rad. That's supposed to be 2 multiplied by 2 pi, because revolution means 2 pi rad. Okay, then per second, that's supposed to be 4 pi rad per second. So that if I also multiply by the radius is supposed to be 0.25 meters. So I'll have 4 pi multiplied by 0.25, 3.14 meter per second. Not, yeah, meter per second is the unit of tangential speed. Tangential speed is meter per second. Tangential acceleration is meter per second squared. But angular speed is rad per second. Then angular acceleration is rad per second squared. So that's just it. Also, centripetal acceleration is meter per second squared as well. So now to find the centripetal acceleration, that's supposed to be linear speed squared upon the radius. That's supposed to be 3.14 all squared upon the radius of that circular motion, and the radius is supposed to be 0.25. So if I do that correctly, I should have 39.4 meter per second squared. That is 3.14 squared divided by 0.25. Now to find the required centripetal force. The required centripetal force is the product of mass and the centripetal acceleration, or mv squared upon r, so that I will need to multiply the mass, which is 1.5 kg, by 39.4, and that's supposed to be 59 Newton. So that's it about circular motion. I also have a video, the part 1 of this video. You can also check that up. It will really help you for circular motions as well. So I look forward to producing more videos on physics and mathematics and other sciences. So I would like you to really subscribe to this channel because it will help you, and share these videos with your friends. Have a nice day.